Hi 7RE, this is Mrs. G. I am going to run class through this video for you guys today. So we are not going to get behind. We're going to keep moving along. This will be lesson 3. So if you haven't yet, go ahead and press pause and take out your notebooks. Take out a pen or pencil to write with. You guys are going to take notes in your notebooks as I explain today's concept. So just like if we were in class, we are going to start with a warm-up. So there are 5 tables here that are kind of this idea of a function rule. I like this machine as a really nice little visual. Something goes in, the machine goes, diddly diddly dee, and it spits out something from the output, and you have to figure out the rule. Okay, you have to figure out the rule that goes from here to here, from here to here, from here to here. Feel free to fill in the question marks, but that's not necessarily the most important part of this activity. What I'd really like you to do is to be able to write an equation that goes from the in to the out. If you want to use the words in and out, that's fine. If you'd prefer to start calling this x and this y, that's fine too. Remember that we use x and y because we commonly like to graph these coordinates on the coordinate plane. So it's linear functions, could be any 2 letters, but we just, as mathematicians, like x and y. Okay, so for the first one, y equals something something compared to x. Okay, so this is our warm-up. I don't want you to get too rowdy. I want you to try and do it mostly on your own, but feel free to press pause and give these a try. And if you're totally stuck, you can work as a group. When you've done with A, B, C, D, and E, all 5 of them, come back to the video and I'll go over the answers with you. Okay, so press pause now. All right, hopefully you are back. You are back with your answers and I will go through them now with you. Okay, so the first table here, hopefully we're getting the hang of this. We're spotting relationships, we're spotting patterns to go from 2 to 4, 3 to 6, and 11 to 22. That's y equals 2x, right? So 2 times x. If you put like y equals 2 dot x, that's fine. Try not to write y equals 2 times x because that looks weird. You got an x and another x. All right, so the best way to write it is just write 2x. We understand that in between these things here is a multiply. Okay, so y equals 2x is your first one. Your second one, all right, the in gets something, the out gets quite big. So what's actually happening there? What's going on? You're probably going to think multiplication and then add or subtract. Okay, so you get a times your in values by some number to get close, and then maybe shift it up or down a little bit. And what's going to get you really close is multiplying by 3. So y equals 3x. And if you did times 3, so let's just pretend here it was only times 3. 2 times 3 would make 6. 4 times 3 would make 12. 7 times 3 would make 21. 10 times 3 would make 30. So then what you want to say is, how do these relate to what you really want? Well, they're all 1 less, so my rule must be times 3 and then plus 1. Okay, so that's a 2-step rule. This is really going to be what we focus on today, these type of equations that have a times and then an add or subtract. And I'll talk to you a little bit more about a real formal process. If you're looking at letter B and being like, I didn't get that, Miss G, I don't know how that happened, that is the objective of today. Okay, I'll tell you a whole process and some tips for doing that. Letter C is the letters minus 1. Okay, so the total letters take away 1. If you count up house, it's got 5 letters and you want 4, 3, that must be 6. You get that? D, you're clearly looking at the eyeballs. So 1 eyeball, 3 eyeballs, and 4 eyeballs. And again, this is kind of similar to the second one where you need some sort of multiplication to get you close, and then you shift. So in this case, y, the output, is times 4. Take away 1. And what am I multiplying by 4? I'm multiplying the little eyeballs by 4. So maybe you wrote y equals 4 eyeballs minus 1. That'd be very cute. But that's the idea. And the last one is fairly tough. So hopefully you had to play with this, and it may have stumped you a little bit. But the hint you want here is that these are all vowels. Okay, so it's got to have something to do with the vowels. Is it the first vowel? Is it the second vowel? Is it the third vowel? Well, actually, it is always the, let me find a good color here. It is always the second one. So here, and the best tip here is toast, actually, and safe, because it's the second one. These are actually not that helpful because there's lots of different vowels there. Okay, and I shows up many times, and E shows up twice, and O shows up a few times. But safe and, safe and toast were kind of your really helpful ones there. People, and then mathematics would be the E. Can't be done. Well, that's going to be anything that's got only one vowel, like the word cat. Okay, so get you primed for the idea of functions. Hopefully you had a good time with those, and let's keep moving on. Okay, so if you haven't written a title yet, you probably haven't because I didn't have it on the previous slide, sorry. So go ahead and write your title. This is Unit 6, it is Lesson 3. We're trying to figure out what is this concept of a function. Okay, so a function is like in a machine. Okay, you put one number in as an input, the machine changes it some way, and it sends it out as a unique output. Okay, so the function machine can be anything, or the rule can be anything, but it has to apply the rule properly. Okay, the function machine can't be broken. Then we would call this not a function. Okay, so if you want to press pause at any point in the video, you want to press pause and write down what I have there, feel free. You don't have to write every single thing down, but try and maybe summarize this. All right, if you're back from writing this down, let's take a look at some examples here. So what if my rule was y equals 2x, like I had in that first one? And if I went in order, 1 goes to 2, 2 goes to 4, 3 goes to 6, 4 goes to 8. You might notice here, these are all multiples of 2. Okay, because you multiplied your x by 2. You might notice that the difference here is plus 2, plus 2, plus 2. And that's key, so keep that in mind. Keep that in mind. Okay, if you want to write this down, feel free. I'm going to change my rule slightly. What if my rule is now y equals 2x plus 1? Okay, so now I have to do 2 steps. I have to multiply my input by 2, multiply it by 2, and then add 1. Okay, so 1, I'm going to do the first one. 1 is going to go to, hopefully you're saying out loud, 3, right? 1 times 2 is 2, plus 1 makes 3. 2 times 1 equals 2, plus another 1 equals 3. Okay, 2 is going to go to 5. 2 times 2 is 4, plus 1 is 5. 3 is going to go to 7. 2 times 3 equals 6, plus 1 gives me 7. I think you're getting the idea. I don't know if I need to write that down. 4 goes to 9, and just for fun, we'll do one more. 5 goes to 11. So what is happening here in the patterns? This is why patterns are so important, why we talk about them in our criteria B. So what happens here? From 3 to 5, from 5 to 7, from 7 to 9, from 9 to 11. If these x values go in a nice, pretty order, 1, 2, 3, 4, 5, well, we can use that to our advantage over here in the outputs and look for the difference. Okay, if your difference is this consistent 2, you have what's called a linear function. This will make a straight line when we graph it. And this connects to the coefficient, the multiplier, the number in front of x. Okay, so whatever constant change here, you have to multiply by 2. Okay, we call this kind of the times table. You're in the 2 times table. Okay, so you're in the 2 times table. Yes, 3, 5, 7, 9, and 11. Those aren't necessarily numbers themselves in the 2 times table. But you're going to first start by multiplying by 2 because that's the change. And then how do you adjust for that? If you were to just times by 2, 1 times 2 would be 2, 4, 6, 8, 10. Multiplying these times 2. Well, how do you adjust? We call the next step kind of the shift. So we add 1 each time to move us to the exact outputs that we want. And that's what's happening here. Okay, so you're always looking for your first difference and then saying, okay, what is my shift? How do I adjust it to be exactly what I want? And that's commonly going to happen with our linear functions. We'll have 2 steps. You'll multiply or divide, and then you will add or subtract. Let's try one more. What if I were to give you something totally different? I'm not going to tell you the rule. What if I were to have 6, 10, 14, 18, and 22? Okay, so what would the rule be here? What is kind of the function rule? What is this machine doing to my inputs in order to get these outputs? Well, the first thing you want to ask yourself is look for the difference. What is the pattern? How are these numbers changing? And hopefully you'll see that they are all going up by 4. Okay, that is important. That's not a coincidence. So your rule is going to be y equals 4x. But we're not done yet. We're going to multiply by 4, but then we're going to shift it a little bit. We're going to add or subtract. What you can do is just kind of visualize your multiples of 4. So 1 times 4 would be 4. 2 times 4 would be 8. 3 times 4 would be 12. 4 times 4 is 16. And 5 times 4 is 20. So what do I need to add to my rule? What is my shift here? What do I need to do with all these multiples of 4 to actually make them the outputs that I want? Hopefully you're saying, Miss G, it's plus 2. And that's your rule. Okay, y equals 4x plus 2. So think about what times table you're in by looking for the change, the rate of change. Yes, that is the rate of change as we learned last time. And then look for a shift. Okay, I'm going to have you guys play a little game online. Should be a good one. It is called, let's see, this is kind of the idea. I think I've already explained this. So look for the times table, look for the shift. It is called shifting times tables. Okay, this is the link here. It's on a website that's called Enrich, and I have put this link on Schoology. Yes, I suppose you could just type that in if you wanted to, but I have copied and pasted this link onto Schoology. Okay, find this little applet sort of thing right on that website and play around a little bit. So click this button that says new numbers, and you'll see a list of values here. Okay, it might be, 7, 9, 11, 13, and 15. And you're going to ask yourself, what is the times table? In this case, it would be the 2 times table. But then I have to shift it. What are the multiples of 2? Well, the multiples of 2 would be 2, 4, 6, 8. Am I lining these up? And then 10. So that's how they line up. And you'll always just start with the very first one as 2 times 1. Okay, so 2, 4, 6, 8, 10. Those are my multiples of 2. And how do I need to shift then? So I times by 2, and then I add, everyone, plus 5. Okay, so that would be my little example there. If you wanted to write that down, just feel free to go back in the video. But I'm in the 2 times table, and I shift up by 5. That is the idea. You can play many times. I would definitely stick with just levels 1 and 2. Otherwise, it gets a little bit hard. Do not sit and do this for the entire class period. Do this for approximately 15 minutes. And if you're absolutely loving it, then 20. But we do have another set of example problems here, and then a homework assignment to get to. Okay, so play around on this website for, like I said, about 15 minutes, and then come back to the video. Okay, so leave my video up, press pause, and when you're done doing that, because you feel like you understand it, come back to me here, and we'll move on to the next activity. When you are done with this, ask the substitute for this piece of paper, and he or she will give it to you. Okay? All right, if you're coming back from Enrich, you've had a good time shifting times tables, I want you to try these 6 tables as they're trying to write the rules. Okay, so now play around, write a real good equation, y equals blah, blah, blah in terms of x. Okay, glue that in your notebook, write your answers, write your little equations underneath these 6. If you really get stuck, yes, of course, I'm going to explain this in the video, so feel free to come back to me, but press pause and give those 6 a try, and then come back for the answers. All right, hopefully you are back for the answers. And the first one, this one isn't so bad. Clearly, we're just adding 4. Maybe you didn't need to do that to say, oh, to go from the ins to the outs, I'm clearly just multiplying by 4. So the first one, y equals 4x. All right. The second one, you're only adding 1. each time. So you don't really have a number here that you need to multiply. What you do is just need to shift. So also maybe in this case you noticed, oh, to go from here to here and all of these, to go from the in to the out, y equals x plus 2. Okay, so that's that one, y equals x plus 2. Letter C. All right, now we are, our change here is to get more negative. We're getting minus 2 each time. So that's just y equals negative 2x. Okay. Continuing on, letter D, same thing. We're going down by 1, down by 1. So y equals a negative 1x. But then what happens? I must be doing plus 3. Okay, that was a kind of tricky one. I had to think about that for a second. All right, what you might want to think about is if you were to just multiply all of these numbers by negative 1, I like to kind of sneak this up here. So 0 times negative 1 is 0. 1 times negative 1 is minus 1. 2 times negative 1 is minus 2. 3 times negative 1 is minus 3. And how do you shift this up to be what you want? You add 3. Another way to think about it is this is your starting point, right? Wherever x is 0, that is whatever you write here. Yeah, wherever x is 0, this is the starting point. We kind of talked about that a little bit. So that's what you have to add or subtract. So there's another little tidbit. Sometimes there's a 0 there. Yeah, that one is there. So that's kind of like plus 0. And sometimes there's not. But if you see x is 0, then that's always what your shift is. That's another little hint there. All right, E. All right, that one there. We're adding 2. So we're in the 2 times table. Y equals 2x. And then how do I shift it? Oh, simple. Plus 1. I think that's the example I gave you earlier. And then this one here. Ooh, lots of 2's. So plus 2, plus 2, plus 2. Y equals 2x. But in this case, I get 1 less than my multiples of 2. All right? My multiples of 2 would be 2, 4, 6, 8, 10. So y equals 2x minus 1. Okay, take away 1. So hopefully you got those. And we are all set for our lesson today. That's kind of all the new information. This is not an easy topic, and I'm sorry that I'm not there to go through it with you, but I will help you when I get back. I'd like you to try homework 10 is what it says at the top, but this is lesson 3. Oopsie. In the homework packet. Okay, so there's 1, there's 2, there's 3. If you got plenty of time, you can continue with the story problem of 3 about the garden. But yeah, there's 2 pages to that one. Skip that. Don't worry about that right there. But this is what you're looking for in your packet. All right, have fun, folks, and I will see you guys. If you're super stuck, I'm happy to talk with you on Wednesday during a break. We actually don't have class on Wednesday, so I will see you next week. All right, have a lovely day.